right. Good morning, everybody. Today is Thursday, December 21st. Happy Solstice 2017. And this is Before the First Cup with Jules here on UCY.TV. Happy Thursday, everyone. It is a chilly and overcast 26 degrees here in upstate New York. So where do we leave off yesterday? We titled the show AI Wins, Valkyerie, Mars, Robots, Avatars, Universal Basic Income, Internet of Things, and SmartEyes. That's a lot. We used some abbreviations in there. We talked a lot about robotics and how they are planning on using virtual reality to send men to space. That gets around that radiation problem. And avatars and utilizing virtual worlds to be able to learn to manipulate and kind of blend reality and fantasy. And that's where we have to worry. It is becoming a real world matrix, and that's where that dopamine button, that addictive button that they use to push to get us connected to our devices, is going to become even more important once they put these goggles up to your eyes and can do all kinds of patterns and flashes of light and video images or realistic images streaming across your eyeballs to be able to manipulate and influence you. And it will get very difficult once you get sucked in deeper and deeper to be able to tell the difference between what is natural and what is not. Well, I think that's where we're going to continue today. What is natural and what is not. But we're not going to talk about virtual worlds. We're going to talk about stuff that they are doing in this world, splicing and dicing things and mixing up the natural order of things. I ran across a couple stories in my feed this morning that sent me down a path. We took a little right turn. We took the right fork. We're going to go somewhere we haven't been in a while, and that is looking at DARPA and some of their synthetic biology projects. A few weeks ago we had looked at some of that, but this gets above and beyond. We've talked about the Living Foundries program, 1,000 molecules. And that was when the DARPA lady came out and said that they wanted to be able to terraform Mars and to fix polluted places on our planet with the push of a button, to be able to create new organisms that can produce things. This would be some sort of biomanufacturing. Well, there was a story that came out of Scientific American in January of 2017. I do remember covering this story, but it'll be a good review almost a year later. DARPA's biotech chief says the 2017 will, quote, blow our minds, unquote. And I got to say, my mind is blown on a daily basis as I go through some of these feeds and start putting pieces together. I got to tell you guys, this stuff really weighs on me some days. You know, it's pretty difficult to juggle this all in. It's like giving a presentation on a daily basis with at least something that people find interesting and connecting some dots. But I got to tell you, it really weighs on me. And it gives me some anxiety. I realized that today as I was listening to some DARPA TV lectures about biology being the new technology and how they're pushing all these buttons and making these reusable components just like a programming language, except they're doing it with DNA and coding from different organisms and putting them into a database that then they can mix and match from different life forms or flip switches on and off to get an organism to produce something as a byproduct that could be useful for the military's needs. So the Pentagon's research division is betting its high-risk, high-reward programs will change medicine. So look out, people, because here it comes. The Pentagon's research and development division, more affectionately known as DARPA, the creative force behind the Internet and GPS, retooled itself 3 years ago to create a new office dedicated to unraveling biology's engineering secrets. This new Biological Technologies Office, more affectionately known as the BTO, has a mission to, quote, harness the power of biological systems. I would include enslave them and design new defense technologies. Over the past year, with a budget of over $296 million, it has been exploring challenges including memory improvement, human-machine symbiosis, and speeding up disease detection and response. DARPA is hoping for some big returns. The director of its BTO, who's a neuroprosthetic researcher, Justin Sanchez, recently spoke with Scientific American about what to expect from his office in 2017, including his work on neural implants to aid healthy people coming for you and me in their everyday lives, and other advances that he says will change the game in medicine. So this is their first question. Before your office was created in April 2014, DARPA had already worked on some biological projects, including research on combating antibiotic resistance. Remember, Obama had an executive order about how we were going to make that national security. Antibiotic resistance is a big deal, and we're all going to die. So let's put lots of money into finding an alternative. And that's where they were looking at some of these not only shape-shifting immune system technologies, but also smart living therapeutics medications, where they could put something into a bacteria that then could get inside your gut and start producing medication inside of you, as well as getting rid of all the quote-unquote bad bacteria that was causing you problems. We're going to talk about a little bit of that later. So what has changed now with the creation of your new office? Well, this is Justin Sanchez says, we have been doing biological work at the interface of biology and engineering for many years, but it was scattered throughout the offices. With our office, there was a recognition that biological technologies were going to play such a crucial role in not only shaping where our country was going, but the threats coming to our country, and we needed a focused, comprehensive effort going forward. So Scientific American asks, I am particularly intrigued by the BTO's hope to develop programmable microbes, ding ding, to produce needed medications on the fly, and I'm going to add inside of your gut, as an effort to sidestep concerns about stockpiling the right drugs or worrying about complex transport logistics. That sounds amazing, but where is that work now? You remember we had talked long ago about, I don't remember the name of the program now, but it was the stockpiling program for experimental vaccinations that the federal government, Congress had to vote on it. I don't remember what it was called. I wish I did. They had to vote on it to dedicate money to purchase from pharmaceutical companies things that might be used, even though they weren't approved for human use or had clinical trials, on the American public if there were no other options. Well, so this is to get around those stockpiles. It is called living foundries, like the foundry where we would build something that is alive. And this is Justin Sanchez. Traditionally, we use chemistry to make new compounds or new drugs. But recently, we've realized that microbes like yeast and bacteria also produce compounds. They can put it in your beer as well. And we can program them to make compounds by first understanding the chemical pathways they use. Take yeast, for example. Yeast uses sugar for a variety of pathways to produce alcohols. And we need to find a cheap sugar, but I'll get to that here later. If you reprogram those pathways, however, you could potentially have yeast build a variety of different compounds that weren't initially designed to make, and you would still use the same feedstocks like sugar. Our team designed the genetic codes that would be needed to reprogram the yeasts, and that is such a different idea about how to revolutionize the way we build compounds. That program set out to produce 1,000 new molecules throughout the duration of the program, and the teams are well on their way, and I believe that they have produced close to 100 new compounds already using the new pathways in yeast. It is all about thinking about biology and marrying it with engineering tools, and then using those two components together to design something. I mean, this really is Crazyville. We are building life at the molecular level, flipping switches that have never been seen before, just to create something that we think is at our beck and call. So you are in the early days of building compounds to spec, as Scientific American. Yes, Justin says, they are on the milligram quantities of these new compounds, but ultimately, throughout the course of the program, we are going to scale it up to kilograms. If we can design these entirely different foundries for building these compounds, we think it could revolutionize how we would think about drug development and also non-medical approaches, because this is a platform technology. Like I said, it's just like a programming language. And depending on what compounds you are interested in, maybe for some medical uses or for some that are building a new material, like something more robust than elements, there are a lot of possibilities. So, what are your most exciting projects for 2017? He says, well, it's like your kids. You can't have just one favorite. I have multiple favorites. Let me share a few that'll be really important to address in 2017. The first is the area that we call outpacing infectious diseases. Now, guys, we have seen the writing on the wall for a very long time since they have been working on these shape-shifting immune system technologies. They can manipulate your T cells, or they can create something that will be able to protect you, whether or not it is an organism that you have ever experienced before. It'll be able to build a defense on the fly like a synthetic immune system. Our current approach, however, is when a new pathogen hits our shores, is that everybody scrambles, and we want to get ahead of any pathogen that may hit our shores and be as ambitious as we can to take pandemics off the table. Well, phew, they got our back. He continues, we have pioneered new work in DNA and RNA approaches to immunization. Yes, you're going to be genetically modified. Specifically, they are thinking about nucleic acid approaches to immunization, and the idea is that you can tell your cells that produce antibodies what the right code is for producing those antibodies that would be effective against a pathogen. So you would get a shot, but that shot would have a code to tell your cells how to respond to that pathogen, and that would lead to a near instantaneous immunity against that pathogen and the ability to really fight against it. So they're going to go and do code injection into your biology. And if you contrast that against the traditional way that we think about infectious disease, where it takes months, if not years, to not only identify the pathogen, but to go through the long manufacturing process to produce the vaccines with big bioreactors and so on, the current process is far too slow for the kinds of threats that are ultimately coming to our country. So you better get prepared. You know, back in the 80s, I read a book called The Stand, and I've mentioned that on the show before. That book scared the pants off of me. It was probably one of the scariest things I had ever thought about in regards to dystopian, apocalyptic scenarios. There's something that gets out of the CDC, and a scientist gets infected, and he makes it out through security and gets into his car and drives all across the state. I think it was Texas. I don't know, maybe not, but for some reason I think it was Texas. And he was heading to get his family, and he crashed at a gas station, and the people who came to help him all got infected then. And it just spread across the entire country. Some people were immune, but most people weren't, and there were lots and lots and lots of dead people. It was very apocalyptic. If you've never read it, I highly recommend you do. It's by Stephen King. I don't know, say what you will about Stephen King, but it was a very good book. And don't go by the TV series, because that one kind of sucked. But anyway, I have for a long time been afraid of a scenario such as that. And guys, they are really lining up a lot of these technologies. There was some competition about Pandemic X that DARPA had run not too long ago, where they were getting companies to compete against how they would fight some known or unknown pathogen in a very short window of time, and I think that was within 30 days. So anyway, DARPA, Justin continues, that is why we took a radically different approach to this fundamental technology, to have DNA and RNA-based approaches to fight infectious disease. I am hoping we'll have some big announcements about that in 2017. Yes, step right up. Come to your FEMA center and get your vaccination for this new pandemic that is spreading quick. It's a deadly killer flu. And if you don't get this new DNA, newfangled synthetic immune system shot, you and everyone you know will perish. I could see them pulling something like that as in the name of national security. So, what sort of announcements, asks Scientific American, and he says we are already getting some good results with mouse models indicating that nucleic acid approaches are working very well. We started down the road of doing some safety work in humans. Oh no. And those are early research steps. We even have every intention in the coming year of building new programs for this end-to-end platform, you being the other end. We look forward to making some announcements about how we are working in this space in 2017 to show that it isn't just an aspiration. This is something we are going after with the BTO, the Biological Technologies Office. If we are successful here, I think it will change the game about how we think about infectious disease. I'm going to tell you, if you remember when there was the Ebola outbreak, we spent a lot of time looking at infectious pathogens in the early days of this show, when there was a lot of that in the news to kind of get it in your head and make you afraid, make you very afraid. When there was an Ebola outbreak, remember how we kind of raised an eyebrow about them sending U.S. troops to Africa to fight Ebola? We're like, oh yeah, machine guns really going to help that. Maybe they're taking vaccines. And one of the things that was interesting is that there were reports that the soldiers going over to Africa had to receive an Ebola vaccine, which might be that small amount of safety work in humans that they had just talked about. All right, so where do we go from here? Let's take a little look at a blurb that I found about DARPA's Living Foundries program, the 1,000 Molecules Award. DARPA has awarded a contract under the Living Foundries program to MIT for the Living Foundries 1,000 Molecule program, and this is in 2015. The award was for a phase one of $11,085. $11 million. How would you even say this? $11,085,634, and a phase two of $10,104,236, and a phase three of another $11,041,546. That's like, what, 11 is 22, and 10 is $32.5 million for MIT to work on this. The Living Foundries 1,000 Molecules program seeks to build a scalable, integrated, rapid design and prototyping infrastructure for the easy engineering of biology. This infrastructure will enable transformative and currently inaccessible projects to develop around advanced chemicals, materials, sensing capabilities, and therapeutics. So where are we going to go on therapeutics? Well, DARPA is now working, and this was October 1st of 2015, with 6 different organizations, not just MIT, on biological materials for military applications. The U.S. military researchers are working with 6 organizations to find ways of developing biological materials easily for advanced sensing capabilities, chemicals, materials, and therapeutics as part of a program to develop a biological engineering infrastructure for the U.S. Department of Defense and for the engineering biology community. Officials of DARPA announced that their latest biotechnology contract went to Zymergen in Emerville, California, for the Living Foundries 1,000 Molecule program, and I have them pulled up here a little bit later. Scientists from these organizations seek to create a revolutionary biologically based technology platform to provide new materials, capabilities, and manufacturing paradigms for the U.S. military. Contractors chosen so far are Zymergen, as well as Ameris. Another one would be the University of Texas in Austin, and then Duke University in Durham, North Carolina, and 20 N Labs in San Francisco, as well as the University of Illinois in Urbana, Illinois. Contractors working on other phases of the DARPA Living Foundries program are Twist Bioscience Corp. In San Francisco, the Regents University of Colorado in Boulder, and the Massachusetts Institute of Technology in Cambridge, Mass. The Living Foundries contractors are helping DARPA scientists as they seek to create the very first of its kind infrastructure composed of tools and processes that will help with innovation across several applications and help push biotechnology forward. The infrastructure will include design algorithms, genetic integration methodologies, and flexible assay systems, and the organizations each are involved with creating one of several research centers. Each will try to produce at least 350 unique molecules of relevance to DoD that will augment today's limited set of chemical building blocks. Biologically produced molecules are more useful than traditional approaches, and the rapid design and prototyping infrastructure should bridge the gap from initial laboratory level proof of concept experimentation to industrial pilot production. The key technical areas of the program include computers to link component technologies, design tools to engineer novel biosynthetic pathways, gene cluster discovery and chemical structure prediction, methods for automatic construction of genetic designs, and design evaluation tools to enable massively parallel testing, analysis, validation, and verification of engineered systems, as well as feedback tools with high volume data generation. Now, I listened to a lecture this morning from one of the DARPA ladies, and one of the things that she said is that they literally could be running tens of thousands of experiments all at the very same time, and they could be doing that with scientists who weren't experts in the field. I was like, oh my God. The insanity ensues. So here's the story now out of the Broad Institute, which is a collaboration of MIT and Harvard. DARPA awarded that very same $32 million that we had mentioned 2 stories ago to MIT and the Broad Institute Foundry to bolster DNA design and manufacturing. A facility at the Broad Institute of MIT and Harvard. Remember Georgie Porgy Church there with all of his genetic CRISPRing engineering that he's been doing. They plan to achieve the full potential of engineering biology, and they have received a $32 million contract from DARPA. The facility at the Broad Institute of MIT and Harvard aims to achieve the full potential, and the foundry, started by MIT biological engineering professor Christopher Voigt and Broad Technology Labs director Robert Nickel, is a result of a partnership between Broad Technology Labs and the Synthetic Biology Center of MIT, of which Voigt is a co-director. The foundry enables the rapid design, testing, and fabrication of large sequences of genetic information so they can be assembled like building blocks, click, 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 for a myriad of medical, industrial, and agricultural applications. The society relies on many products from the natural world that have intricate material and chemical structures, from chemicals such as antibiotics and materials such as wood. We have been limited in our ability to program living cells to redesign these products. For example, to program living cells to create materials as intricate as wood or seashells, but with new properties. Rather, products from synthetic biology have been limited to small, simple organic molecules, and I want to change the scale of genetic engineering to access anything that biology can do. And I had read earlier that in that award that was going to the University of Texas at Austin, they also had the J. Craig Ventnor Institute working along with them. This technology is quickly scaled from deciphering a single human genome to examining thousands of organisms, including everything from soil bacteria to elephants. And the Foundry is now working to realize an analogous revolution in designing and writing DNA, for which instructions for useful biological functions are converted into physical DNA chunks that can then be put into living cells. This effort will be supported by DARPA funding derived from the agency's Living Foundry 1000 Molecules program, which seeks to establish facilities that can rapidly engineer cells to make chemicals and materials not found in nature. Key phrase, guys. This is becoming a bigger petri dish than we ever imagined. They're going to create living organisms not found in nature. What can go wrong? All right, so where do we continue? Well, this was the story that I ran across this morning that got me going down this right fork in the road. It's out of the New York Times. A federal ban on making lethal viruses has been lifted. Oh, really? The National Institute of Health will create expert panels to assess controversial research into creating pathogens that can easily infect humans. Well, phew, don't you feel safe? Federal officials on Tuesday, and that would be 2 days ago, ended a moratorium imposed 3 years ago on funding research that alters germs to make them more lethal. Such work can now proceed, says Dr. Francis S. Collins, the head of the National Institute of Health, but only if a scientific panel decides that the benefits justify the risks. Some scientists are eager to pursue the studies because they may show, for example, how a bird flu could mutate more easily to infect humans. Of course, we want to know that. Or it could yield clues how to make a better vaccine. Critics say that these researchers risk creating a monster germ that could escape the lab and seed a pandemic. Oh, yes, they aren't hoping for that, are they? Especially with DARPA working on all this biological technology. No. Critics say that researchers are now all gung-ho, and now the government panel will require that researchers show that their studies in this area are scientifically sound and that they will be done in a high-security lab. Now, when we dealt with things such as pathogens before, we had found a whole spate of faux pas and big oopses that happened at the Department of Defense as well as the CDC. There was that whole anthrax shipping to hundreds of offices around the globe of anthrax that they thought was dead because they had killed it with x-rays, but then they discovered that it really wasn't. And then they had the smallpox that had been sitting around unsecured for 50 years. I always say it was on top of a filing cabinet, but no, it was actually in a refrigerator at the CDC. So then they went, oh no, we don't really have the biosecurity that we could have. We found out there was something else, and maybe it was even anthrax again, that somebody was transporting in a Ziploc baggie. It's just awful. So, and the other one was Plum Island. They moved Plum Island from off the coast on an island off of New York City right to the heartland to Manhattan, Kansas, in the middle of Tornado Alley. And, a lot of the stuff that we've been looking at, if you will see pictures of labs or any of this stuff, one thing I've noticed is that they don't seem to be wearing lateral gloves or face masks as they're splicing and dicing and creating these cells. No, I haven't seen any high security labs, but anything that I have seen, I don't really see that there is a high level of security being taken in some of this work that is being done. And because they have democratized the stuff where you could DIY gene edit across the globe, who knows what is going on in places that we can't see. So anyway, the pathogen to be modified must pose a serious health threat if we're going to let you do it. And the work must produce knowledge such as a vaccine that would benefit humans. Finally, there must be no safer way to do the research. Otherwise, we're not going to let you tinker with these deadly pathogens. We see this as a rigorous policy, says Collins, and we want to make sure that we are doing this right. In October of 2014, all federal funding was halted on efforts to make 3 viruses more dangerous, and that would be the flu virus, as well as those viruses that cause the MERS, which would be the Middle East Respiratory Syndrome, as well as the SARS, and that would be the severe acute respiratory syndrome, and that would be the ones that showed up in the Middle East and the ones that showed up in China. But the new regulations apply to any pathogen that could potentially cause a pandemic. For example, these regulations would apply to a request where they wanted to create an Ebola virus that was transmissible through the air. Oh, yeah, of course they would be thinking about that one. And there's been a long, fierce debate about projects known as the gain-of-function research intended to make pathogens more deadly or more transmissible. You guys remember there was a big controversy when scientists were crying foul, where they told them that they could not publish the results on how to make the 1918 killer flu more virulent, as well as the lethal bird flu that they have been working on, and they published not one but 2 publications showing how to make that more killer. In 2011, and I think this is exactly that, an outcry arose when laboratories in Wisconsin and the Netherlands revealed that they were trying to mutate the lethal H5N1 bird flu in ways that would let it jump easily between ferrets, which are used to model human flu susceptibility. Tensions rose in 2014 after the Center for Disease Control and Prevention accidentally exposed lab workers to anthrax, as well as shipped a deadly flu virus to a laboratory that had asked for a benign strain. That year, the National Institute of Health also found vials of smallpox in a freezer. So it was the NIH, not the CDC, that had been forgotten about for 50 years. So when the moratorium was imposed, it effectively halted 21 projects. And in the 3 years since, the National Institute of Health has created exceptions that funded 10 of those projects. 5 were flu-related and 5 concerned the MERS virus. That virus is a coronavirus carried by camels that infected about 2,100 people since it was discovered in 2012, and it has killed about a third of them, according to the World Health Organization. Critics of such research had mixed reactions. There's less than meets the eye, says Richard H. Ebright, a molecular biologist and a bioweapons expert at Rutgers University. Although he applauded the requirement for review panels, he said that he would prefer independent panels to government ones. Of course he would. He also wanted the rules to cover such research rather than just government-funded work, right, because it's happening everywhere, as well as clearer minimum safety standards, ding, 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 and a mandate that benefits outweigh the risks instead of merely justifying them. Mark Lipsitch, an epidemiologist who directs the Center for Communicable Disease Dynamics at Harvard School of Public Health, called review panels a small step forward. A recent disease-enhanced experiments, he said, have given us some modest scientific knowledge and have done almost nothing to improve our preparedness for pandemics, and yet the risks creating an accidental pandemic, yes, accidentally or on purpose, as I frequently say, and therefore he said he hoped the panels would turn down such work. Michael T. Osterholm, director for the Center of Infectious Disease Research and Policy at the University of Minnesota, said he believes some laboratories could do work safely, but he wanted restrictions on what they could publish. If someone finds a way to make Ebola more dangerous, I don't believe that it should be available to anyone off the streets, yes, who could use it for nefarious purposes, like how to make it airborne. Physicists have long learned to distinguish between what can be publicly available and what is classified, he added, referring to nuclear weapons research. We want to keep some of this stuff on an as-needed-to-know basis. Of course they do. Let's publish it all, put it out there, all in the name of democratization. All right, so I came across a publication out of ScienceDirect.com titled A Brief Overview of Synthetic Biology Research Programs and the Roadmap Studies in the United States. This is from October of 2016. The United States is leading nation in the world in the development of synthetic biology, and oh yeah, we should be part of that one, an emerging engineering discipline to create, control, and reprogram, ding ding, biological systems of which you and I are a part of, with strategic investment from government agencies. The U.S. has established numerous research centers and programs in synthetic biology, enabling significant advances in foundational tool development and practical applications ranging from bioenergy, biomanufacturing, to biomedicine. To maintain its leadership in synthetic biology, the U.S. has conducted several roadmap studies that provide strategic visions and action recommendations. And here we will provide a brief overview of the major research programs and the roadmap studies of synthetic biology. Synthetic biology promises to provide sustainable solutions, and that's how they're selling this, guys, to many grand challenges of the modern society via innovations in agriculture, chemicals, pharmaceuticals, energy, and bioremediation. Given its interdisciplinary nature, however, the consensus definition of synthetic biology is yet to be reached, but at its core, the field of synthetic biology centers on design, construction, and characterization of improved or novel biological systems using engineering design principles. Although synthetic biology is becoming a global research enterprise, the U.S. is a leading nation in the world. In 2000, 2 U.S. research groups reported the creation of genetic oscillators and toggle switches that function in an analogous manner to electrical circuits, like flipping switches, which makes the birth of synthetic biology field. And since then, the U.S. government has been the biggest investor on this emerging discipline, providing approximately $500 million to $1 billion in research funding since 2005. And you remember we found out that DARPA was one of the biggest funders of gene drives. Many U.S. research centers focused on synthetic biology have been established, including but not limited to Synthetic Biology Engineering Research Center, and that would be long for SynBio. the Centers for Synthetic Biology at MIT, and the University of California at San Francisco, as well as the J. Craig Venter Institute. Moreover, U.S. industry has also been investing heavily in the medical and biotechnological applications of synthetic biology, with an expected market value of $10.8 billion just in 2016. So to go up and up and up after that, remember we are only in the beginning. And exemplary companies are from multinationals such as DuPont, so that's got to make you feel good, BP, like in the Gulf, ExxonMobil, to then startups such as Synthetic Genomics, Ameris, Interexon, Ginkgo Bioworks, and Zymergen. In this review, we'll briefly summarize the research landscape of synthetic biology in the U.S., focusing on major funding agencies and research initiatives. So, all right, we have the National Science Foundation has funded UC Berkeley for a program doing synthetic biology engineering, and that was for the Sinberg Center. The Department of Energy has funded the Oak Ridge National Lab for the program of the DOE Bioenergy Science Center. Another Department of Energy funding for the University of Wisconsin and Michigan State University is called the DOE Great Lakes Bioengineering Research Center. The DOE also financed Lawrence Berkeley National Lab for the DOE Joint Bioenergy Institute. National Institute of Health has three. There's the UC San Francisco, MIT, and the Rockefeller University, which is more affectionately known as Stanford. For these three programs, the Center for Systems and Synthetic Biology, the MIT Center for Integrative Synthetic Biology, and the Genomes to Natural Products program, to trick you out. And then DARPA has two programs, and that would be the Living Foundries ATC&G and Living Foundries 1000 Molecules that went to the University of Texas, Caltech, and the J. Craig Venter Institute, as well as UC Berkeley, MIT, Harvard, and University of Colorado, as well as Zymergen and Ameris. U.S. major research agencies that fund synthetic biology, and we just read about them. That would be the National Science Foundation, the Department of Energy, the National Institute of Health, and the Department of Defense, including DARPA. And there was one more that they list down below, and that would be NASA as well. And remember, NASA had Elon Musk fly him up MRSA so they could experiment with it in space, because they found that germs in space tend to grow faster and mutate to become more virulent. Dependent on the specific missions, different federal agencies have their own focuses on synthetic biology. For example, the National Science Foundation aims to advance fundamental basic research, develop novel engineered systems, educate new cadres of students, and support an emerging synthetic biology industry. The DOE is focusing on the development and the application of synthetic biology tools to redesign plants, microbial, and hybrid systems to manufacture biofuels and bio-based products. And that was like the tobacco plant we had read about. The National Institute of Health is interested in fundamental and translational research areas where biomedical science and synthetic biology overlap. The DOE considers synthetic biology as the one of 6 basic priorities of research because of its potentially transformative impact in defense applications, including smart sensing, novel materials, and medicine. For NASA, 3 focuses are material resupply en route and the destination for human missions, astrobiology, and next-generation aeronautics, including the use of biofuels and fuel additives. Moreover, synthetic biology may also impact many USDA strategic plans, such as expanding agricultural markets, food safety, your nutrition, and your health. And here we will highlight 4 U.S. government agencies who are now major sponsors, and then they go on and on and on. I think I need a breath, and we're going to switch gears. All right, so now out of MIT News, engineers design living materials. Hybrid materials combine bacterial cells with non-living elements that can conduct electricity or emit light. Inspired by natural materials such as bone, a matrix of minerals and other substances, including living cells, MIT engineers have coaxed bacterial cells to produce biofilms that can incorporate non-living materials such as gold nanoparticles or quantum dots. These living materials combine the advantages of live cells, which respond to their environments, produce complex biological molecules, and span multiple length scales with the benefits of non-living materials, which add functions such as conducting electricity or emitting light. These new materials represent a simple demonstration of the power of this approach, which could one day be used to design a more complex device such as a solar cell, a self-healing material, or diagnostic sensors, says Timothy Liu, an assistant professor of electrical engineering and biological engineering. Liu is a senior author of a paper describing the living functional materials in a March 23rd issue of Nature Materials. Our idea is to put living and non-living worlds together to make hybrid materials that have living cells in them and are functional, says Liu. And this is an interesting way to think about material synthesis, which is different from what people do now, which is usually a top-down approach. The paper's lead author is Alan Chen, who is an MIT, Harvard, MD, and PhD student. Other authors are postdocs, such as Xingtao Deng, Amanda Billings, and blah, 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 as well as another MIT graduate or two. Liu and his colleagues chose to work with the bacterium E. coli, and that was the one that Georgie Porgy Church worked on, because it naturally produces biofilms that contain so-called curly fibers, and that is curly, C-U-R-L-I, which are amyloid proteins that help E. coli attach to surfaces. You know, amyloids are what they were saying were responsible for Alzheimer's. And this is the second story that I've seen where they have mentioned creating amyloid proteins. Each curly fiber is made from a repeating chain of an identical protein subunit called a CSGA, which can be modified by adding protein fragments called peptides. These peptides can then capture non-living materials such as gold nanoparticles, incorporating them into their biofilm. But by programming cells to produce different types of curly fibers under certain conditions, the researchers were then able to control the biofilm's properties and create gold nanowires. Oh my God! Which are conducting biofilms and then films studded with quantum dots, which are tiny crystals that exhibit quantum mechanical properties. Guys, this is building a little quantum machine that then can get inside of you. E. coli is a gut bacteria that can show up. This is pretty frightening. They are engineering the cells so they could communicate with each other and change the composition of the biofilm over time. So they're making a little nano network that can go inside of living organisms. First, the MIT team disabled the bacterial cell's natural ability to produce CSGA and then replaced it with an engineered genetic circuit that produced CSGA, but only under certain conditions, specifically when a molecule called AHL is present. This puts the control of the curly fiber production in the hands of the researchers, who could then adjust the amounts of AHL in the cell's environment. And when AHL is present, the cells secrete CSGA, which forms curly fibers that coalesce into a biofilm, coating the surface where the bacteria are growing, and then maybe even creating little gold nanowires to implant themselves. I mean, this is like Invasion of the Body Snatchers, guys. The researchers then engineered E. coli cells to produce CSGA tagged with peptides composed of clusters of amino acid histidine, but only when a molecule called an ATC is present. And this is getting pretty technical. These two types of engineered cells can then be grown together in a colony. And I am going to guess in your gut, allowing researchers to control the material composition of the biofilm by varying the amounts of chemicals. The researchers also demonstrated that cells can coordinate with each other to control the composition, and it is a really simple system, but what happens over time is you get curlies that are increasingly labeled by gold nanoparticles, and that shows that indeed you can make these cells that talk to each other and that they can change the composition of the material over time, says Liu. Ultimately, we hope to emulate how natural systems like bone form, and no one tells bone what to do, but it generates a material in response to environmental signals. Almost sounds to me like they're trying to make some sort of like synthetic stem cell or something to create them whatever system they are creating. To add quantum dots to the curly fibers, the researchers engineered cells that produce curly fibers along with a different peptide tag that is called a spy tag. Interesting term there, a spy tag, which binds the quantum dots that are coated with a spy catcher, which is a protein that is a spy tag partner. These cells can be grown along with the bacteria that produce histidine tag fibers, resulting in a material that contains both quantum dots and gold nanoparticles. These hybrid materials could be worth exploring for using in energy applications such as batteries and solar cells, and researchers are also interested in coating the biofilms with enzymes that catalyze the breakdown of cellulose that could be used for converting agricultural waste into biofuels. Other potential applications include diagnostic devices, of course it does, and scaffolds for tissue engineering when they're going to 3D print your new kidney. I think it is really fantastic work that represents a great integration of synthetic biology and materials engineering, says Yuling Chong Yu, an associate professor of biomedical engineering at Duke University, who is not part of the research, and I bet he's really jealous. This research was funded by the Office of Naval Research, the Army Research Office, the National Science Foundation, the Hertz Foundation, the Department of Defense, the National Institute of Health, and the Presidential Early Career Award for Scientists and Engineers. Well, you know what's interesting is I swear that I dreamt about a company called the Hertz Foundation yesterday. Maybe not. I'll have to look them up. Where do I remember them? Because I'd never run across them except from what seems like a dream before today. So, all right, where do we go from here? So now let's look at a couple of these different companies that were given funding by DARPA. DARPA offers $30 million to jumpstart cellular factories. And this is June 29th, 2011. So this is already almost 7 years ago. The Defense Advanced Research Project Agency, more affectionately known as DARPA, which is the U.S. Defense Department's high-risk granting body, is about to jump into synthetic biology in a big way. One of the latest research buzzwords, synthetic biology, means many different things to many different people, but for the new DARPA program, it represents modifying the metabolic and genetic machinery of cells to produce useful products. We want to create a new manufacturing capability in the United States, says DARPA. Approved barely a month ago, the $30 million Living Foundries program should be sending out a request for proposal in the next few weeks, making awards to several months from now. And that would be the one that they granted at MIT as well as University of California at San Francisco and other agencies. It'll support academic and corporate researchers for developing and applying engineering frameworks to biotechnology for biomanufacturing. And they want to bring new players to the field. Well, how about this one? And this is one that was listed in one of those publications that we had read. I don't think we actually got there, but there was a list of names. And one of those names was, we did, Ginkgo Bioworks, which struck me as interesting because it almost sounds like it's some sort of healthy, green, new group that's going to make some sort of probiotic, maybe, that'll make you safe utilizing Ginkgo biloba. There's a little mind F going on there, but guess what? It's not. And it even has not only funding from DARPA, but also Bill Gates. This was a brand new story, December 14th, 2017. So that was a week ago. Out of TechCrunch.com, Ginkgo Bioworks secures $275 million in Series D funding, which now brings the valuation of the company to over $1 billion with a B dollars. Boston biotech startup Ginkgo Bioworks has announced the raising of $275 million in Series D funding to build out its Bio 3 production facility. The funding comes from previous investors, including Viking Global, Y Combinator Continuity Fund, Cascade Investments, Bill Gates, as well as a new investor called General Atlantic. The company previously raised over $154 million, bringing the total up to $429 million in 3 years since launching out of Y Combinator. The new raise now puts Ginkgo's valuation at over $1 billion, according to the sources. Ginkgo started using yeast to create products for flavor, fragrance, and food industries, and it has produced probiotics, really, in conjunction with DARPA to help U.S. soldiers stave off stomach bugs they might pick up overseas, wink, including creating bacteria that can decrease farmers' reliance on chemical fertilizers and living medicines, ding, 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 that can cure the body of disease. Well, it's got to make you feel good that they are creating all these things with funding from help from DARPA, but they were using yeast that produce flavoring, fragrances, and things for the food industry. Oh, really? Remember a long time ago we had talked about some of those new bacillus additives that I was finding in strange places, such as in tea, that says, now with probiotics. Always be afraid, be very afraid. When you see that on a package, something that doesn't seem like it should be healthy, like potato chips or tea, or where probiotics might not survive from boiling water like tea. And raise an eyebrow to that. Take a closer look as to what type of quote-unquote probiotic they are using. Last year, Ginkgo raised $100 million in a joint venture with a pharma company named Bayer. Oh, yeah, we know Bayer. To create a bacteria that can decrease farmers' reliance on chemical fertilizers by focusing on nitrogen fixation. This new funding will be used to branch out into even more markets next year. There will be more and more consumer goods being impacted by biotech. And rather than honing in on one material, Ginkgo is a sort of the backbone, work in a partnership with these types of companies, and Ginkgo designs and ships the bugs, and the companies do all the rest. Yeah. Right now, the biggest deals are the company have coming from agriculture and pharmaceuticals. They also mentioned the possibility of going public soon. Keep in mind, the company didn't just pop out of Y Combinator just a few years back. It was founded in 2009, and it already has about 15 people on a team when it entered into the accelerator in 2014. It does make a lot of sense for us to sell the company or seek an acquisition because of just the breadth of the markets that we touch. For us, this is a standalone new industry, more of an organism design industry. It is exciting to see all of this happening in this new biotech space, particularly with startups and synthetic technology companies raised more than $1 billion last year, and it might just go beyond that for the end of 2017. And it'll be interesting to see what Ginkgo does with its new Bioworks 3 Foundry over the next few months. The production facility officially begins operations today. And they said they were going to create probiotics for soldiers overseas and, of course, living medicines. All right, and maybe that was part of that living therapeutics that we had talked about a while ago. So last but not least, one of the other companies that they had mentioned in that one document was a company named Ameris. Ameris joins the Sweet Fleet, and DARPA lends a hand May 3rd, 2017. So not only are they doing work on probiotics and things to make you better in medicine, but they are also working on making new synthetic sweeteners where they can get rid of the high fructose, genetically modified corn syrup, and add something new. Back in September of 2015, they're getting it into our food, people. We already knew that, but it is coming fast and furious. This is May 3rd, 2017. Back in September of 2015, this Biofuels Digest reported that Ameris inked a multi-year agreement with the U.S. Defense Advanced Research Project Agency, more affectionately known as DARPA, that gave us everything from Kevlar to global positioning to the Internet. And the goal of this $35 million agreement with the Biological Technologies Office was to create new research and development tools and technologies, compressing the time to market for any new molecule by at least tenfold in both time and cost. The story expanded this week in May of 2017 when we heard from Ameris that it had completed strain engineering and optimization of at least 26 key metabolic precursors along multiple organisms, including many different pathways beyond terpenoids, allowing Ameris to develop an industrial-scale fermentation process for virtually any biological molecule. In addition to the expansion of the range of metabolic precursors, Ameris has revealed that it now has expanded its high throughput yeast strain construction and testing pipeline to several other industrial relevant organisms. DARPA's Living Foundries program was, of course, a part of this, and they then got funding to go ahead with the development for a scalable source and supply. Well, Marillus has come out with a new sweetener, not completely unrelated to Marillus. Newfound chops and a strained construction is news that Amaryllis has made quote-unquote significant progress in the development of its healthy sweetener product, which of course is going to be in all the junk food out there, and expects industrial production to occur in 2018. We reported earlier this week in our sister publication about this, and now we are reporting it here. Amaryllis is making a no-compromise sweetener and says that it is on track to be the low-cost leader at industrial scale production with natural-like sweeteners with very low calories that is sustainably sourced from things. Amaryllis's target is to sell the world's leading sweetener at a lower cost than sugar without any negative taste. Consumers love soda, but they hate sugar, and Amaryllis wants to make the soda taste the same and be healthy. Can you even believe it? The company expects that this product opportunity in partnership with its partners to deliver over $100 million in annual revenue by 2020. One of the things that this announcement portends is a step beyond conventional sugars as a feedstock in conventional ways. A note that Amaryllis will be selling lower cost than sugar rules out starting from conventional sugars in a conventional way. So the one possibility is the company could be targeting something like xylitol, which is a C5 sugar and used as a sweetener, or sorbitol, which is a C6 sugar, that alcohol that the human body metabolizes more slowly than conventional sugars. A patent search has not yet revealed any particular targets coming out of Amaryllis. We reported last December that the Institute of Chemical Research in the Swiss Federal Institute of Technology researchers found a way to get sweeteners like mannitol or ribitol from cheap renewable sources like glucose. And so now that they can recognize sugar atoms, researchers have found a way to get the valuable polyalcohols from regular sugar easily and more affordably to make candy and things of that nature. So anything sweet is going to be tainted. The race for the next big sweet tooth satisfier has been heating up significantly, and this is the next generation. We reported in April that Cargill is another one of those big agri-tech companies, and Evolva inked a major collaboration pact for the production of the commercialization of EverSweet. All right, put in a seatbelt, guys. I will catch up with you tomorrow. Everybody,